Hello everyone, welcome to Mind Maps. This is part 4 of electronic spectra of transition metal complexes, and we are here to discuss the Orgel diagrams, right? So we have a D1, we have D1 configuration, 5 d orbitals. This is Eg and this is T2g. Now when you fill the electron, it can occupy any of the two T2g orbitals, okay, any one, dxy, dyz, dzx, okay, and Eg will remain 0. So what are the possible combinations? Okay, first we'll put an electron in dxy, the other two will remain empty. Then we can put one electron in dyz and finally in dzx. Okay, so we have 3 combinations in ground state. Alright, now just come back, and when this electron of T2g goes into Eg, okay, goes to Eg, let me take another color. When it's in Eg, there is one electron in Eg, okay. What are those combinations? dz square, dx square minus y square. So we can write 1 0 0 1. So there are 2 possible arrangement in excited state. So we can now say that 3 is greater than 2. So this is more stable. This one is less stable. This has, ground state has less energy. This has more energy. Excited state has more energy. So finally, when we draw the Orgel diagram, okay, so Orgel diagram is nothing but this. We have Eg, then we have T2g. This is for D1 octahedral splitting, right? Is that okay? Now we shall consider D9 configuration. Okay, so what happens in D9? We'll just fill the okay, sorry, I just drew the reverse thing. There's no eraser. Okay, so we have Eg and T2g. I'll just put 9 electrons. These are the 9 electrons. Now what you need to think about is, okay, this space is empty. This is called a hole. Okay, this is a hole. Is that all right? So in ground state, What are the possible combinations? dxy, dyz, dzx. Okay, this will remain the same. 1, because these are completely filled. Okay, this is one combination. Then we have dx square minus y square, dz square. Okay, we have 1, 1, 2, or 2 and 1. So we have a total of 3 arrangements. In excited state, ground state. Okay, now what will happen in excited state? So in excited state, we'll just promote one electron to Eg. Okay, so in excited state we have this combination. Eg is completely filled and T2G is partially filled. So we'll again calculate the energy calculations or arrangement of electrons. Okay, so Eg dz square or dx square minus y square, these will have 2 electrons. Okay, this is one combination. And dxy, dyz, dzx. Okay, so these are the 3 combinations, right? So in excited state we have a total of 4 combinations. We'll just go back. Okay, in ground state we have 3 arrangements, and in excited state we have 4 arrangement. So did you see the paradox? That means 4 is greater than 3, which is more stable, less energy, right? Similarly, this is less stable, more energy, right? This is excited state and ground state. So what happens in D9 is the excited state behaves like the ground state. Okay, here the splitting of orbitals is changed. Okay, so what we have here is T2G, okay, which we thought was lesser in energy, but it has more energy. Why? Because of less arrangement, and Eg is, so the role is reversed. Okay, so this is D9 of octahedral complex. Okay, so the Orgel diagram will be like this. Now what happens in tetrahedral? When we draw the splitting, okay, in CFT we studied these are 5 d orbitals. In octahedral we have Eg and T2G. This is octahedral. And in tetrahedral we have E and T2. Okay, the terms reverse, but we don't have a G here, okay, because of there is no symmetry. So we see that the role is reversed. So finally, when we draw the Orgel diagram for D1 octahedral, okay, it's like this from the discussion, EG T2G, okay, and for octahedral it's the reverse thing, okay. Here we have the T2G and EG, okay. Why I'm writing this? Because D9 follows this pattern, okay. D9 becomes octahedral like this, and the reverse is true for D9 tetrahedral, and D1 here becomes tetrahedral, okay. So this is the combined Orgel diagram of D1 D9. Similarly, we can do the same for D6 and D4, okay. The diagram is somewhat similar. What you can do is you can draw the electronic states, microstates, energy states, calculate the arrangement and construct an Orgel diagram on your own. You will get something simply like this Orgel diagram, okay, but that you have to figure out where do you write D4, okay. So this was Orgel diagram, okay.